Now, I'm going over the homework that we had from Friday. So question 1 asked us to draw a graph of y equals sine x in the domain minus 360 degrees to 360 degrees. So a little bit different from what we had on the notes, because we didn't do the negative ones, but I had told you that it repeats the same pattern in the negative direction as well, and we can use our calculator to calculate the different angles. So I'll very quickly do an input-output table. My x values are going to go from minus 360, and I said let's go in 45 degrees or 30 degrees. I actually like to do 30 degrees, so minus 330, minus 300, minus 270, minus 240, minus 210, and we keep going like that, okay? Now, when you're doing your input-output table, you might fill in all the values, but I want to show you how we can get away with not doing that. The sine of x then, we use our calculator, sine of minus 360, shift sine of minus 360 is 0. Sine of minus 330 is a half. I'm going to go for decimals, 0.5. Sine of minus 300 is root 3 over 2, minus 8.7, or minus 0.87, and minus 270, 1, minus 240, back at 0.87, minus 210, back at a half. We'll keep going. I'll do a few more here. Minus 180, going to be back at 0. 180, back at 0, minus 150, we're at negative a half, minus a half, minus 120, it's going to be minus root 3 over 2, which is minus 0.87. So you can start to see, sorry, that's off the screen. You can start to see the pattern that's occurring there. Right, so drawing the graph. We need to draw a graph that goes between minus 360 and 360 and goes up and down between 1 and minus 1. Let's move this slightly. Get the focus a bit sharper. There we go. Okay, and this needs to go between 1 and minus 1. And we'll use 1, 2, 3, 4, 5, 6, 7, 8, 9. I should have gone down one actually. 10 boxes so that I can mark in my halfway point as well. 0.5. And then down here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, down to minus 1, 1, 2, 3, 4, 5, at minus a half there. I'm going to mark in these endpoints here as being minus 360 and plus 360. And then I start to plot my points. Now, if we do our input-output table like this, going up in 30 degrees, we'll have a lovely accurate graph, we'll have lots of points, and that's great, but it can be a little bit time consuming. So my halfway point here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 12, 15, 16, 17, 2, 3, 4, 5, 6, 7, 8. Here's my halfway point, 180 degrees. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 6, 8. Halfway point there, 180 degrees. So we're just going to estimate the halfway points in between these as well. Halfway between here is minus 270, and then we have minus 90, 90. So this is why 45 degrees is sometimes good as well. And we have 90 here. And usually this is enough actually. Okay, if I'm reading some of my points from here, minus 360, 0 is one of the points on the line. Make my points stand out, I'm going to use this. I've got the point 0, minus 360. I've got a whole bunch in between before I get to minus 270, but it's minus 271. So it's up here, minus 271. And then we had minus 180. We were back down at 0 again. Minus 150, which I haven't filled in here, was at the half point. So we might, if you want to fill in the half ones, you can. And so I didn't go any further than that, but I can start to use my calculator as well. And I can say sine of minus 90, sine of minus 90 is minus 1. So I'm actually all the way down here now. And then I'd like this point here in the middle. So sine of 0. Sine of 0 is just 0. So that's a point on my graph as well. Then sine of 90, if you put it into your calculator, is 1 all the way up here. Sine of 180 is 0. Sine of 90 is, that's not 90, that should have been 270. Sine of 270 is minus 1. I'm down here again. And sine of 360 is 0. So if you remember that the shape of sine, the basic shape of sine is that it's going up and down like this, in between minus 1 and plus 1, then we can draw our graph really quickly from here. And if you went and did out all your input-output table entries like I had there and plotted them in detail, that's fine. This just makes it a little bit quicker. And I need to draw a sketch of my graph. Now, if I go ahead and try and draw this straight away, I'm going to end up with a zigzag. It's really important that my graph be a smooth curve. So take your time with making it a smooth curve and use a pencil to do the graph. All the way up to there, and it's not coming to a point at that top. Should be a smooth curve coming down here as well. It's not super accurate. It's never going to be as accurate as a computer is going to do for you. But so long as you have that basic shape. Now I'd get full marks for that, but I think it's worth going over a little bit stronger. Draw my graph and make the line super clear and make the curve of the line really obvious. Like that. Okay, so that's the graph. We should label our axes, the y-axis and the x-axis, and this is the graph of sine of x in that domain. Now, you mightn't feel comfortable working with that small number of points, so if you want to do a few more, that's fine as well. Excuse me. Let's look at the second question you had for homework. Copy and complete the table here. We have to find sine of x, and we'll just go to maybe one decimal place for each of these. So sine of 0 is 0, sine of 45 degrees is about 0.7, sine of 90 is 1, sine of 135, 0.7, sine of 180 is 0, sine of 225 is minus 0.7, sine of 270 is 1, sine of 315 is 0.7, so we're back up again, sine of 360 is 0, sine of 405, I need to double check now, 0.7, just double check 315, sorry, this was minus, 0, 0.7, sine of 450 is 1, sine of 495, 0.7, and sine of 540 is 0. So we want to plot these points on a graph. Same idea as what we had earlier. And then use our graph to do an estimate. Okay. Just this camera. So we're drawing our graph in between 0 and 540. I'll come all the way over to the side this time. And I want 20 boxes up and down. 3, 6, 9, 12, 15, 18, 20. And I'll just go a few more to give myself plenty of space. 3, 6, 9. Go here. Oh, made a mistake there because I want it over here. Because I'm starting from 0. I don't want my y-axis in the middle. I want my y-axis all the way over to the side. Just move this up a little bit. So I can use a rubber to get rid of that middle one. That's fine. I'm going to draw our x-axis coming out like this. And I do have to plot all the points this time. So we will mark in 34 of them. There's 540. So here's my halfway point. 540 divided by 2 is 270. And then I can work from there. Divide that by 1, 2, 3, 4, 5, 6. Okay, so this will be my 45 degrees, 90 degrees, 135, 180, and 225. Same thing here. 315, 360, 405, 450, 495. And I plot my points. I tend to plot my points in pen and do the rest, just to make them stand out. Do the rest in pencil. So you have 0, 0, 45, 0.7. There's 1, 3, 6, minus 0.7, and minus 1. Second point, third point. You can see the shape of the graph taking shape now. 225 minus 0.7. 270 minus 1. 270 was minus 1, not 1, as I filled in, just to show there. Now I filled in 270 as 1, but 270 is minus 1. 270 is minus 1. $315 minus 0.7, 360, 0, 405, 0.7, 451, 495, 0.7, and 540 back at 0. So there's my sine, and I need to do my smooth curve. This. We come all the way down like this. Okay, so there's the shape of my sine graph. And the second part of the question asked us to use the graph to estimate the values of x for which sine of x is minus 0.5. So they're saying that y is equal to minus 0.5, the output of my function. So minus a half, and I find it on my graph. I didn't mark in my halves. That's 0.5, and that's minus 0.5. So I said we find that on our y-axis, and then we draw a horizontal line through it and find the matching, I'll just do a straight one like this, find the matching x values for that. So here, coming up like this, so there's one x value, and the second one is here, and there's my second x value. So I have to do a bit of estimating here. This is a little bit more than halfway between those. So that looks like it's around 205 degrees. Okay, well, let's see what happens when we put that into our calculator. It may not be exact. So sine of 205 gives me minus 0.42. And that's just because my graph is a little bit inaccurate. Maybe 210. 210 would be exactly right. Okay. It's just in terms of reading my graph, but that'll be fine. I'll get full marks for that. Depending on how accurate your graph is, this was the answer that we actually should have had. And here, so x is halfway between 315 and 360, so about 340, a little bit less than that, so about 330. X is about 330. And again, we'll just check in the calculator, sine of 330, that's minus a half. So you can check in the calculator as well, but it needs to look accurate on your graph as well. If your graph is wrong, but you use it correctly, you can still get full marks for these parts here. So the values of x for which sine of x is minus a half are x equals 210 and x equals 330. If you just do this on your calculator with no marks on the graph, you will get 0 marks for this. Okay, so it's really important that you show this horizontal line and these lines coming up to the x-axis like this. Now, Tonight for homework, so we've spent quite a lot of time going through this, so I'm not going to go to the notes today, but for homework what I want you to do is a question where you're plotting cosine. We haven't looked at the notes for plotting cosine yet, although they're filled in on Google Classroom as well, but I want you to try it anyway. If you get stuck, I'll be making a video going through it, and we will go through the notes in it as well tomorrow. Okay, thank you very much.